Exploring our cosmic neighborhood, a journey through the solar system. The solar system is our cosmic neighborhood, a vast collection of 8 planets, dwarf planets, moons, asteroids, comets, and dust. It all revolves around our star, the Sun. The solar system is about 4.6 billion years old. It formed from a giant cloud of gas and dust that collapsed under its own gravity. As the cloud collapsed, it began to spin. Most of the material pulled inwards to form the Sun, while the leftover material flattened into a disk around it. This disk of material eventually clumped together to form the planets, moons, and other objects in our solar system. The solar system is made up of the following. The Sun, a giant ball of hot plasma that provides light and heat to the solar system. 8 planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. The planets orbit the Sun in nearly circular paths. The first 4 planets, Mercury, Venus, Earth, and Mars, are rocky planets. They are relatively small and have a solid surface. The outer 4 planets, Jupiter, Saturn, Uranus, and Neptune, are gas giants. They are much larger than the rocky planets and do not have a solid surface. Dwarf planets: these are celestial bodies that are round and orbit the Sun, but they have not cleared the neighborhood around their orbit. There are 5 dwarf planets currently recognized by the International Astronomical Union: Ceres, Pluto, Haumea, Makemake, and Eris. Moons: natural satellites that orbit planets. There are hundreds of moons in our solar system, with Jupiter having the most, 79 moons. Asteroids: rocky objects that are left over from the formation of the solar system. They are mostly found in the asteroid belt, which is located between Mars and Jupiter. Comets: icy objects that orbit the Sun and develop a coma, a tail of gas and dust, when they get close to the Sun. They are mostly found in the Kuiper belt, which is a region beyond Neptune, and the Oort cloud, which is a huge sphere of icy objects that surrounds the solar system. Dust: tiny particles of rock and ice that fill the solar system. Evolution of solar system. The solar system's story is one of birth, growth, and eventual change. Here's a breakdown of its evolution. Birth: 4.6 billion years ago. It all starts with a giant molecular cloud, a cold, dense region of gas and dust in space. A shock wave, perhaps from a nearby supernova, triggers a collapse within this cloud. As the cloud collapses, gravity pulls most of the material inwards, forming the Sun at its center. The leftover material flattens into a swirling disk, the protoplanetary disk, around the young Sun. This disk contains dust, gas, and ice particles. Growth: millions to hundreds of millions of years. Within the protoplanetary disk, dust and ice particles clump together due to collisions and gravity. These clumps grow over time, forming rocky bodies called planetesimals. Closer to the Sun, the intense heat vaporizes lighter elements, leaving behind rocky planets like Mercury, Venus, Earth, and Mars. Farther out, where it's colder, ices can condense along with rock, forming the cores of gas giants like Jupiter and Saturn. The leftover icy material beyond Neptune clumps to form the Kuiper belt and the Oort cloud, reservoirs of comets. Collisions between planetesimals are common, shaping planets and sometimes creating moons. Some massive impacts are thought to have reshaped Earth, creating our moon. Change and the future, billions of years to come. The solar system continues to evolve. Asteroids and comets left over from formations sometimes collide with planets or moons. The Sun itself is slowly changing. In billions of years, it will run out of fuel for hydrogen fusion in its core and expand into a red giant, potentially engulfing Mercury and Venus. Eventually, the Sun will shed its outer layers and become a white dwarf. The remaining planets will likely continue to orbit the white dwarf, but the solar system as we know it will be vastly different. This is a simplified overview, and there's still much to learn about the solar system's formation and evolution. Scientists continue to study objects like asteroids, comets, and distant planetary systems to piece together the details of our cosmic neighborhood's fascinating history. Life in Solar System. Life in the Solar System, is anyone out there? The vastness of space has always fueled our curiosity about extraterrestrial life. While we haven't found conclusive evidence of life beyond Earth yet, our solar system holds some intriguing possibilities. Scientists are actively searching for signs of life, particularly microbial life, on several celestial bodies. Here's a glimpse into some of the most promising places. Mars, the red planet with a past. Mars is our closest neighbor with a compelling case for past habitability. Evidence suggests that liquid water once flowed on its surface, and it still has polar ice caps and possibly subsurface water. The thin Martian atmosphere provides some protection from harmful solar radiation. Some studies have hinted at seasonal methane fluctuations, which could be a potential biosignature, a sign of biological activity. Europa, Jupiter's icy moon with a hidden ocean. Europa, a moon of Jupiter, is a captivating candidate in the search for life. This icy moon conceals a vast subsurface ocean, possibly salty and in contact with the rocky core, creating an environment that could potentially harbor life. Europa's icy crust may be spewing water vapor into space, which future missions like the Europa Clipper by NASA could analyze for biosignatures. Enceladus, Saturn's moon with a spouting ocean. Enceladus, another moon of Saturn, is similar to Europa in holding a subsurface ocean. What makes Enceladus stand out are the water plumes erupting from its icy surface. The composition of these plumes suggests the presence of possible hydrothermal vents on the ocean floor, which could create environments suitable for life as we know it. These are just a few of the promising targets in our cosmic neighborhood. Other moons like Titan, Saturn's moon with lakes and rivers of liquid methane, and even Venus, with its possible past habitability, are being explored for their potential to hold life in forms that may be vastly different from what we consider normal. The search for extraterrestrial life is a thrilling area of scientific exploration, and with upcoming missions and ever more powerful telescopes, we may soon have a much clearer picture of where life might exist in our solar system, if at all. Stay tuned.